What's up, guys? I was just feeling that. Yeah, that's all I got. That's my Coach Jay at home.
All right, well, there you go, right there. Hey, YouTubers, Swedish family, how are you doing? It's part 3 of Coach Jay. Oh, is that? Oh, look at that. It's like Inception. All right, hey, we're gonna get it underway, and we're gonna go part 3 of the review. Hopefully, we have some different questions there, and we are going to get this show underway. Okay, let's do this right here. Okay, let's go to this one. And questions. Let's go. Let's get it rolling. Part 3. Number two. Okay. Remember on simplifying, right? Simplifying, our goal is to try to multiply, divide, or simplify, right? To try to take things top and bottom out of there, okay? So as we look at this, we want to factor first, right? So what can I factor the top to? Good, x plus 6 and x minus 3. So we're going to factor that out in that way. So we're going to go x plus 6 and x minus 3. Yes, DT? Yeah, so on the bottom, we kind of do the same, right? It is a difference of 2 squares. So x squared minus 36 turns into what?
X minus 6.
Good, x plus 6 and x minus 6. Now, tomorrow, or Thursday rather, when you take the test, on the restrictions, I'm requiring you to do restrictions for 4 problems. And I'll tell you which ones, and because I list it right there. When you do that, remember you do it before you actually cancel out. So what can x not be equal to here? And negative 6. Yeah, good, good, good. Now what could I cancel?
X plus 6.
Yep, x plus 6, x plus 6. To leave me with x minus 3 over x minus 6 as my answer. Okay? All right?
So, like, I mean, x can't equal 6 or negative 6. The x minus 6 in the denominator is okay.
Yes, that's true. We could have x minus 6. What we're saying is we don't know what the value of x is. We don't care what the value of x is, but it can't be 6 because it would produce an undefined answer.
Okay.
It's all the stuff in the denominator, right?
Only the denominator. Good, Bruce. Yep, you're exactly right. Okay. All right. Other questions?
That's it.
That's it on that one.
Cool.
Do you have any other ones we have not gone over? The back side we haven't hit on very much, so if you see those.
23.
23, let's look at it, okay? Actually, I will tell you this right now. Toughest problem on the test, number 23. One similar to 23, okay? Okay, toughest problem. Now, I already went through number 22, which is a little easier than the one I'm about ready to take on. But here's the thing. When you approach one like this, here's what I do every single time. I ask the question, what are we solving for? Okay? So in this one, what does it say we're solving for? P, okay? Now there's 2 of them, okay? Since there's 2 of them, that's okay. We can still have 2 of them there. We want to get all of the ones with P's on one side. That's the goal. So whatever has P, we're going to get on one side. So how can I get rid of this bottom PR? Yeah. We're going to multiply it by it, right? Okay? To get rid of it on that one side. So when I do it, what I do to one side, I do to the
Other.
Yep, that's it. Okay? Very good. I love the participation. So now what we have is this. We have P, R, big T equals A minus P. Okay? But remember, okay, and if you need to, you can keep circling it. We're trying to get where anything or any value with P we get on one side. Now, we don't quite have that yet, do we?
No.
What do I need to do? Add P. Good. So we want to get this one to the other side. So what we have is PRT plus P equals A. Now, have we done that? We got everything with P on one side? Okay. Now, does anyone know what I could do with this to be able to solve?
Oh,
Taylor. That's a good idea. That you're close. You're really close. You're going to divide by something. DT, you know?
Can you divide by 10?
Still good. That's a good idea. Not quite. Arena, do you know?
RT.
Not quite. Okay, so question. What's in common on that left? Y'all are correct on this, but what's the same on the left side? So what's the GCF? I mean GCF. What's in common? P, right? So if I took out a P, what would I be left with? Plus? Plus 1, right? You got to leave a 1 here. Now question, if P is multiplied by RT plus 1, what do I do to get P by itself? Now you say divide by RT plus 1, okay? And so we'd have A over RT plus 1 equals P, okay? It's just tricky. It's just a tricky one there. The one that's previous to that, number 22, is one that is a little easier. But on 23, one like that, where you have two kind of values you have to factor out, there will be one like 23 on the test. You want to make sure you kind of look over that again, okay? So those of you that are from Sweden watching this will be on your test, all right? Okay? I legit have, this is completely true, I have people that watch like my podcast that I do not know who they are. Like legit.
How do you know if they're from Sweden?
I don't know. I just say it out there.
I just think that's cool to say.
Yeah, well, I just maybe. Yeah. Yeah. Maybe. Okay, let's go to another one. Y'all have another one? 32, is that good?
Yeah, that guy.
Okay, let's do that guy. Okay, so anytime I have an interval notation, right? Or anytime I have a inequality that we have here, greater than or less than, or greater than or equal to, less than or equal to, we're going to solve it just like any equation, okay? Same idea. So we're going to solve for x here, and we're going to solve for x by isolating both sides, okay? Getting x on one side, whole number on the other. So what can I do to simplify?
Distribute negative 2.
Yeah, let's distribute -2, okay, to each, to get what here?
-x plus 6.
-2x plus 6 minus 25, right? Okay. All right, good. Now, what can I do to simplify maybe that right side?
6 minus 25.
And we would get 6 and -25 to get? Yep, -19. Good. Now, here's a note. This is just a side note on this. Anytime I get this, it makes it a lot easier if I get x on the left side, okay? So if you get x on the left side, it makes it easier, okay? Yeah, it would be that you could still do it, but it just makes it, you'll see it a lot more with x on the left side than on the right. Still can do it, but it's just a little easier, okay? So for instance, and I'll show you why in a second, what could I do to get x by itself? Okay, and what could I do with that 5? Subtract 5, right? So this is gone, leaving me with what's 6x and 2x? 8x is greater than, and what would be this right side? -24. Good. Okay. So now when I divide by 8, x is greater than what? -3. Now, do I flip the sign here?
No, only when it's negative.
It is negative.
Good, Maddie. Good. The only time I do this is if 8 was negative, then I would have to flip it, okay? But once I get to this point, Brooks, this is why I did it. Once I get to this point, if x is on the left side, it's an arrow that shows me if x is greater than, that we can start at -3 and the arrow will be going to the right side. Does that make sense? Okay. By the way, would that be open or closed? Open, right? Okay. So this right here is not interval notation quite yet. Okay. So let's graph this. This will be at -3. Open, going to what side? Yeah, it's going to the right side, correct? Okay. Open circle, or you can put a parenthesis, right? Okay. So the question, this is interval notation, and if we need to go back up to one, we can. What's the furthest left value in this graph?
-3.
Okay. What's the furthest right that it's going to go? Okay. So we're going to do -3. The furthest right is infinity. And would this be a parenthesis or bracket? Parenthesis, why? Because it keeps going, right? So infinity is always parenthesis. Okay? Yeah, go ahead. Okay, maybe this will help you over here, Jordan. If you have a bracket, that is the same as like equal to, which is the same as greater than or equal to or less than or equal to. Those are all three the same. Okay.
Does it matter which side we put the -3 on in the infinity?
It does because the first value is the furthest left it goes,
Oh yeah.
and then the right value is the furthest right it goes. So I would say from -3 to infinity, right? And what would be with -3?
Bracket.
Parenthesis, because it's an open circle. Got me? And it's because it's just greater than. But if it was greater than or equal to or filled in, then it would be a bracket. Does that make sense, y'all? JD, does that make sense?
Yeah, now because I see where you over.
We'll
I
do.
always thought that was like with the bracket. You always with the bracket when it was like where as far as it could go. So that's how I always thought it.
Gotcha.
That's it.
Yeah, it means greater than or equal to or less than or
The
equal
open
to.
circle means greater than or less than.
Open circle means it just means that it's greater than or less than. It doesn't have an equal sign underneath, is what we're saying. Does that make sense? And so this is interval notation here. This is the graph, and we call that an inequality right here, or just like call it set builder notation, but you don't need to know that. So this is interval notation and then the graph. So that's just a heads up there. Okay?
So if there was a greater than or equal to sign, then
Hey y'all, let's make sure we keep it down so we can hear. Claire?
would there be a bracket around the -3? And then the parentheses still in the infinity?
If this was filled in,
Yeah.
yes, and it would have to be greater than or equal to, right?
Okay.
But yes, absolutely.
So is there always a parentheses around the infinity?
Yes, anytime infinity or negative infinity will always be a parenthesis, okay? Check out, let's try 27. How about that? Because that one's kind of the same thing, because y'all had some questions on that. This one just says graph on a number line, right? So on this one, what would be the furthest left value?
-2.
Yeah, -2, right? So- Yep, we got it here. Why is it an open circle?
There's no bracket.
Parentheses.
Yep, parenthesis. Very good. And what's the furthest right this is going to go?
Infinity.
Infinity. Very good. And so we'll just do it like that.
Is that what you want us to do for the line? Do a squiggly line?
I never did that before. I usually just did a solid. And yesterday I was helping out a student and they did that. And I was like, that's kind of cool. So I'm starting to do it.
Alright. Okay.
Trendsetter. I like it. You can do it. You can do either way. It's fine.
Wait, can you tell did you do number? Wait, did you say they did number 26 already?
26 we haven't done,
Can you
no.
do that? 'Cause, like,
Yeah.
I don't know if it's a shade out or in.
Absolutely. So remember, anytime we have an interval notation, we're talking in terms of the furthest left is the first number and the furthest right is the second number, right? So what's the furthest left this graph is going to go on that? -3. Good. Is it going to be open or closed?
It's close.
Good. Yeah. And what's the furthest right this is going to go?
5.
Good. So we'll put 5 up on top. Is it going to be open or closed?
Open.
Good. And what will happen then? Well, because it's like between, like the furthest left is -3, the furthest right is 5. We're going to then say, okay, then we're going to graph in between that -3 and 5.
Okay.
Okay? It's a good question. Good question there. All right. Do y'all see any other ones that you're like, I'm kind of confused on this one?
Number 19
19? Yeah, we could do that. X squared minus 9?
equals 0.
Okay. So what could I do with x squared minus 9 equals 0?
You know, you got two
Solve.
different squares.
Yeah, you could like do a perfect square, right? Which would be what?
X plus 3, x minus 3.
Good. And once I factor this out, how do I solve for x? Yeah, set them both equal to 0, which is kind of both numbers, right? So if I set x plus 3 equal to 0 and x minus 3 equal to 0, x would be equal to what two numbers?
Plus or minus 3.
Yeah, plus or minus 3 or 3 or -3 is good by me. Okay?
Add the 9 at the beginning, then do the square root and get plus minus.
Yep, because if you square to square, you get plus or minus. You can do either of those two, okay? Either of those two there. All right, any other questions on this?
You do 21.
21? Yeah, it's a good one. It's a good one, Claire. All right. 21, I did hit on quite a few of these too in previous ones, but this is a good one. Just to kind of give a heads up on. Now, when I solve, someone give me a strategy. What can I do when I solve here? Common denominator, right? Okay, you're gonna find that this one becomes a little different, all right? And I would highly recommend just kind of making sure that you know how to do this one specifically. DT?
So when you break down the first one, x plus 4,
And?
x plus 2,
Good. And so what would be my common denominator?
that right there,
Good. X plus 4 and x
plus 2,
plus 2. Good. So what are we missing from here?
nothing.
Nothing. So we're good here, right? What about this one?
Plus 2,
X plus 2. What do I do to the bottom? I do to the top. What am I missing on this one? Okay. Good. Okay, so what do I do now? I'm solving, right? Which gives me a hint, right? When I add and subtract, I keep the denominator, right? But what do I do when I solve once I have a common denominator?
They're all on the same.
put all on the same thing.
Okay, I can do that. Absolutely. That would be adding and subtracting, right? And I could do it really here. But one thing that would make it easier is if the denominators are the same, get rid of them, right? Make it easy on yourself. So if I do it to one side, as long as it's the exact same on the other side, I can do that as well. And that's why we do the common denominator first, okay? All right, how are we doing on this? Okay, so we're left with 2x equals x times x plus 2. It becomes a little strange, and you'll see why in a second, okay? So we have 2x equals, what about x times x plus 2?
X squared plus 2x.
Good, nicely done. X squared plus 2x. What about negative 2 and x plus 4?
Negative 2x.
Good, and just be careful that this negative right in the middle, that's got to go, what's that? This one right here on that side's got to go to both of them, x and the plus 4, okay? All right? All right, very good. They don't know how short I am. For them, I'm 6'3". No, they don't. It might be a tall board. So the Swedish people is right. So right when I see x squared, I would right away get that everything to one side, okay? So get this equal to 0 by subtracting 2x, okay? All right, so what I've got is 0 equals x squared. What about 2x, negative 2x, and negative 2x produces what? Good. And minus 8. Now, here's why it gets a little strange. Because now I've got to try to solve for this, which, how could I do that? Factor out. So what two numbers multiplied?
4 and 2, so minus 4 plus 2.
Good. Man. And x minus 4, x plus 2. So what does x equal?
4 and negative 2.
Good. 4 and negative 2. Very good. But what can x not be equal to?
Negative.
Negative.
Negative. No.
Isn't it negative 4?
4 and 2. It's not negative. Wouldn't it be 4 and?
Okay, so both of these are positive, right? If I set both of these equal to 0, what could x not be? This is the bottom, right? Right? This was the bottom, x plus 2, x plus 4.
Yeah, that was
X cannot be equal to negative 4, negative 2. So which of these answers can I not have?
Negative 2.
Negative 2. Good. So we would cross off negative 2 and be left with just 4. Okay? So x equals 4, or x cannot be equal to that right there. Okay? More work, please. But if you need some more room, you can ask me. I'll give you some paper.
I didn't put as much. I didn't put all the work. I put a lot of it.
Yeah, just show me a little bit. Show me a little bit.
Be sure to count off points for pieces.
Is that what we're doing? Count them off?
Yeah.
Do that.
His name is Bert.
All right. Any other questions y'all have as you see it there? Any other questions? Y'all are G to G. What about number 31? Are you all good on that one?
No.
Yeah, do that, guys.
All right. Good answer. I'll pay you later on that one. All right.
Thank you.
That's it. Yeah, it really is just kind of the same thing. Well, Gabby, what's the common denominator there? Okay. Actually, it's just greater than. Yeah, so 12 would be kind of the common denominator, right? Now, I will tell you this, even though this is easy and it's not as some people think it is, at least here, some people think it's maybe an easier one. One thing that a lot of people will forget is kind of right in the middle, and I'll show you in a second. What number multiply gets me 12 here? Good, so we're going to do top and bottom. What number here?
3.
Good. All right, so I skipped this one, right?
No.
Good. What should I put?
12.
Good. That's one thing that a lot of people forget is that even though it doesn't have a denominator, it still must have a common denominator to be able to go forward, okay? All right. What about this one? 6, good. Okay. And so once I get this, all of these are going to be 12, right? So what can I do? Cross them off. Okay, leaving me with 4x minus 9 minus 12 is greater than 6x. Okay. This is actually a really good one because you'll see why I do now.
Here's what you can do. Can't you add them up first?
We could subtract 4x. That's fine.
No.
Okay.
You want the x on this side.
A lot of times
Or do the
we
what's
want.
it called first. Oh
Say-
wait, no, never mind.
Just do
I'm gonna get confused. What's it called? It's the same thing.
Gotcha. Either way, you can still do it that way. Just remember, if you put it on the right side, you can then flip-flop it back, okay? I might do this just to keep it consistent. Let's make sure we move this x to the other side, and that way we can keep it consistent. Not to say that it's wrong, though, okay? You could still do it. So we're going to subtract 6x.
Wait, why can't you do the other way?
You can, but you'd get the x on the right side.
Oh,
To
no,
where-
you
have to flip
If the x is on the right side, you would have to flip the x in the whole number and then flip the sign. So if you put the x on the left,
Then you're fine.
you know that it'll be consistent there, okay?
Yeah.
But it's not wrong. You could do it that way. So now we're left with negative 2x. What would be here? Minus 21 is greater than 0, right? What do I do to get 21 over?
Add 21.
Good. And what do I do to get x by itself?
Divide by -2.
Okay, if I divide by -2, because it's a negative number, we're right. We have to switch the sign. So we'll be left with x is less than negative 21 over 2. And that right there, answer, okay? All right? Good. So this is saying what? X is what? Less than negative 21 over 2, okay? So if x is less than negative 21 over 2, what would be the furthest left this would go?
Negative infinity.
Okay? If you have to, you could graph it, right? So if this is negative 21 over 2, where's the graph going?
Negative infinity.
Going to the left, right? Where's the furthest left?
Negative infinity.
Good. Where's the furthest right?
Negative
Good. And is this a bracket or a parenthesis?
Parentheses.
Good. Is this a bracket or parenthesis?
Bracket. Oh wait, no, wait, parentheses.
Parenthesis because it's right. And so that would be interval notation, okay? All right?
He's using my cam scanner.
Gotcha.
Don't worry about it.
We're good, everybody. Everybody, we're good, okay?
Yeah, I was. I mean, I was thinking
All right. Any questions at all? Are we good on that? Okay. As far as everything else goes, 34, let me just do 34 to get that on here. 34, if we had x to the fourth minus 16, how would I factor that?
x squared
You take out 2.
minus
Okay, can I factor out a 2 yet?
No, I meant this one. This one I meant.
X squared and x squared, right? We have a plus and a minus because of the negative. What's the square root of 16?
4.
4, good. So we have x squared plus 4 and x squared
Minus 4.
minus 4. Can I factor out x squared minus 4?
Yeah.
2,
X minus 2x plus.
good. And then we just leave the x squared plus 4 there as well. So that's factored out as best we can.
Why can't you factor out? Why can't you do
The x squared plus 4, there's no way of doing that. We haven't looked at like how to, like that's an imaginary number if I were to solve that. And it's not, yeah, we don't want to get to that yet. We'll get to that later. Does that make sense though?
So only if you have a minus one.
Can I actually do what we call dots, difference of 2 squares? Yes. Okay. 36? Yes, we can. Okay. 36, let's look at it. And all right, so 7, x to the 5th, y to the 6th. By the way, this one will be on there, or one similar.
this one? Will?
One similar to this, yeah.
Oh,
Memorize
I
it.
know this.
This one's all good.
That's right. Memorize this one. You're good. Okay.
When it be
Okay, so 7 and 28, what do we get there?
4,
Good? Yeah, we're going to put 4 on the
bottom.
bottom, right? Because the larger number was there. So we have x to the 5th, y to the 6th here. X to the 15th, y to the negative second. Now, some of you do it differently, right? And that's fine. We could do this. Let's just bring both of these up to the top. So say that again. You're exactly right, Gabby. That's exactly right. So we'd have x to the 5th, y to the 6th. If I brought x to the 15th up, what would that change to? Good. And if I brought y to the negative 2nd up, we bring it'd be y to the 2nd. So Gabby's right. Y to the 6th times y to the 2nd gets me y to the 8th. X to the 5th times x to the negative 15th gets me. Good. And then we still have that 4 on the bottom, right? Okay. Now, if we want exponents positive, what do we do with x to the negative 10? We're going down for real? I'm sorry. It should be x. My fault. I got.
Wow, Coach Jay. Are you even a math teacher?
No, I'm not. I should stop.
Why would 8?
Y is y to the 8th. When I bring y to the negative 2nd to the top, if it is y to the negative 2nd to change it, put it to the top side, you would change it to y to the 2nd, right? So then you'd have y to the 6th times y to the 2nd. You add those exponents to get y to the 8th. Does that make sense?
I got eggs.
You see that there now? Again, you do it differently. Some people subtract, some people, and that's fine. That's fine. I just do it this way to keep it there.
Is that you flipped that there because of the negative 10, right?
Correct, because it was x to the negative 10, but I changed it to the positive there. You go from there, okay? All right. Hey, I know we've hit on a lot of these. Are there any other ones that you see that we haven't covered yet?
No, number 7.
Number 7?
Yes.
Okay. Ooh, this one's good. What's the common denominator?
It's the same.
Squared minus 9.
Okay, good. So we have 2x minus 7, right? Now, the cool thing about this is since it already has the common denominator, let's just leave it as x squared minus 9, right? Because there's nothing, we could factor it. We can't because we're not solving, right? You see the difference? Here, you'll have to keep it because we're just subtracting. We're not trying to actually like solve for x, okay? Now, what happens with this negative?
Don't you got to distribute it? So it'd be negative x plus 2.
Good, so we have 2x minus 7 minus x plus 10, right? Now, once I simplify that, what would I get?
Well, you get x.
Now, do you see something like weird about this one?
Now you got to do the perfect square of 9, right?
Which would be what?
X plus 3, x minus 3.
Good, because of the minus in the middle, right? Yeah, that's the difference of two squares. What could I cancel?
X plus 3,
To equal what?
x minus 3.
Yep, but it's not just x minus 3, it's
1 over x plus 3.
good, DT. 1 over x minus 3, where x's cannot be equal to?
3.
And?
Negative 3.
That's it. Good.
Great job, DT.
Good job, DT. Good work. Good work.
How many points off on our test are we gonna get?
Well, first off, if you forget it, well, remember, on this, Jordan, remember in solving, those are the real important ones because that could affect the whole answer, right? But the other ones, I've actually said state the restrictions. So on the test, I have a spot for says like a blank that is state the restriction. I might make it like half the question, plus it's there. So just put it there.
You want to try one?
Come on.
Number 11.
Number 11? Okay. Hey, let's get these on here for my YouTube followers out there. That's right. All 2 of you. Yesterday, I did a podcast for Pre-Cal 12. 0 people showed up. I literally talked to myself. It was like legit talk to myself. So I was just like, what's that? Like that? That's right. All right, what can I do with this one? Can I simplify this at all?
Where?
What about the negative 2?
Like you can distribute it.
Yeah, let's distribute, okay?
So you can have negative 12.
Negative 12? plus
You got 2x.
2x, right? Gotta get that 2 in there. And so we don't care where the x is on this one as much because there's no inequality. We're just solving. So what could I do now?
Subtract 2.
Good. Subtract 2x, right? And when I cancel, what do I get on the left?
1 minus 12.
Which is?
11.
Negative 11 equals?
X plus 2.
Good. So what do I get to get x by itself?
Minus 2.
Good.
Subtract 2.
And x is equal to?
13. Negative 13.
Negative 13.
Negative 13. Good. Hey, one thing too to remind you about is if you were like, I don't know if that's right, plug it back in. You got time, check them by plugging them back in on that. Now, this is a side note, and this is my last thing, and then we'll be done here, okay? What if at the end of solving, and this is kind of important, what if I got like no x, like it was 0x, it was gone, it was done,
No solution.
and I got, well, be careful. What if I got 2 equals 2 on either side? Is that true? Yep. So you're gonna say, you could say true or true dat or what, I don't know what y'all say.
That way. I'm gonna say that way.
And then we'll say all reals, okay? Okay? Now what if I said 2 equals 1?
No solution.
That's false, right? And so you could say no solution,
So you must be from the south side.
and that is it. Amen. Okay? All right. YouTube followers. It's part 3. The trilogy. What's up, Claire? The trio. If you want to be on it, come on. Let's go.
Just know, I'm DT and I look good.
Hey everyone.
Here's all the answers.
Go follow me on
I don't know what this
Instagram,
is, but we're
all
on
that,
there.
you know. Snapchat, all that.
Mannequin challenge.
Hey,
Brooks is winning.
Hey,
the great
have a great
number
one.
6. See you later. Just know that DT love you.
I'm leaving.
All right.
I'm leaving.
Don't leave right now. I'm leaving though. Have a great day. Trilogy coming right at you. Bye.
On this.
Bye.